I was leading the AI section in that startup. All right, and I have participated in a couple of hackathons and won prizes. The one was Code Fund to Plus Plus 2018, where I was a winner from my college, and Axel 2019, where I represented my college. And again this year we had a hackathon, and then I won. And Ideathon was another hackathon where I participated. My areas of interest are artificial intelligence, blockchain, DevOps, web dev, augmented reality, cloud computing, and also some electronics like Arduino and IoT. Right, we can get connected on LinkedIn. Just follow this link, and we can stay connected. Right. So coming to today's agenda, what are we going to cover in this whole session, right, of one hour or something? So first we'll be seeing what do you mean by cloud, right? Then what is Microsoft Azure, what is AI, what has ML Service and Studio to do, demos, and we'll have Q&A. You guys can also follow up with me when I'm doing the demos, right? All you need is just a Microsoft account where you can do the things what I'm doing on Machine Learning Studio along with me, right? Is this a suggestion? I prefer it doing side by side. So it's up to you. If you're watching on a mobile, then it won't be comfortable. If you guys are using laptop, then go ahead and have a login with your Microsoft account, and then you're good to go. So let's just cover what is cloud and cloud computing in brief. I'll not go much in depth into this particular topic, as this is not the agenda of today. But if you want to know more about this, we had conducted a webinar last week, and the recording is up on YouTube on LearnMate's channel. I'll be giving out the link in the group WhatsApp group which we have created. You guys can go there, and there's an in-depth session on what cloud and cloud computing means. So what do you mean by cloud in short? Right? Cloud is nothing but you get your computing resources over the internet. Let's say you are planning to host your website, right? What do you need? You need a server which is up and running 24/7. Let's say you are planning to make it a e-commerce website, right? What happens then? Let's say there is a festival like Diwali or something. Your sales will go high, right? Yesterday, I guess there were CBSE also faced the same issues. There were not frequent users, no frequent users for the CBSE website initially. But what happened? Yesterday there were results, and all of them rushed at once. So there was a huge server hang up, right? And many of them were not able to access the results on time. This is not new. It happens every year. Right. So what is the solution for this? The solution is cloud. Why cloud? Cloud is because it's elastic. I'll just tell you the benefits of cloud later, but let's see what cloud means. In simple, it is just delivery of computing resources over the internet, right? What are these computing resources? What do I mean by computing resources, right? Virtual machines, right? Virtual machine is one of the computing resource. Serverless, right? I'll just show what serverless means, right? Then we have containers. Containers, I think you guys might have heard of Docker, right? So all those resources will be provided to you over the cloud. So again, what are the compute servers? Okay, compute or servers, they just mean that network community machines that are located in data centers, right? What do you mean by data centers? Well, data centers are managed by individual service provider like Microsoft, Google, Amazon, or IBM as well, right? So what do they keep in that particular data center? Just a quick confirmation, is my screen visible? You guys can use the chat option and tell me, is my screen visible? All right. Thank you. Thank you. Am I going too fast, or do you want me to go slow? Is the speed okay, or should I go faster? Okay. So compute servers, right? I was discussing on compute servers. I mean the data centers, right? Let's say a room, right? Air conditioned room where you have stacked up your electronic components, what you call servers, microprocessor units, MPUs, not microcontroller units can't be used, MCUs can't be used, but MPUs are the most preferred ones. But again, a much more complex MPUs what you can think of, right? Just like your system, what you have in front of you, something like that, with a higher GPU and CPU capacity. Those are placed in that particular data center, right? And you know the heating issues, right? When you use a laptop for gaming, let's say, what happens when you play a game for a longer time, right? Your laptop gets heated. Then some of them provide the cooling pad for that particular laptop so that, you know, the device doesn't get heated up very much, right? Similarly, imagine your data center which is, you know, handling that amount of data. So obviously there will be, you know, heating issues which are very, you know, uh, what do you call, persistent there. So what you can do, they have a full setup there where, you know, there are air conditioned rooms at particular temperature, regular checks are being taken place, right? So that all happens in a data center. Coming to the next part of the cloud, which is, you know, like extensively used these days, the storage capacity, right? I'll just tell about this in detail when I go ahead, when I deal with big data, right? So storage or the databases, there are a lot of type of databases available, right? So you can't have a huge database, like let's say a huge memory in your system to store all the data. So what do you need to do? Let's say, for example, you use Instagram, right? There is a lot of data which is being generated every day. Do you think it is feasible to store it in a laptop or in a some remote place? Obviously no, right? So what happens at that time? They go ahead with the cloud services, and that is where you have this databases available on the uh, cloud. Then comes artificial intelligence or analytics or something like that, right? So this is where today the industry is excelling a lot, right? Every cloud service provider has his own solution to artificial intelligence. So what do you mean by intelligence? Well, like, I'll just discuss it later. Intelligence is nothing but how you interact with people, right? It's not about scoring marks or, you know, excelling in something. It is just how you act, how you respond to the to your environment. That's what I mean by intelligence in this whole concept when I refer to that. Okay, let's see how did this evolve over the time, right? Initially, there was mechanical, what do you call, some chips and all developed initially, right? Then it turned into a grand calculator in 1877, right? Then it came ahead with electronics. Again, there was huge revolution in that, and it came into AT&T order, right? And then shaky reasoning robot. I mean, the first robot was developed in 1969. If you just look into the history of AI, right? AI is not a very new term. It is existing from a very long time, right? So the first robot was in 1969. Then there were computers after that, then graphical using interfaces, right? Like what you use Windows, a very good example for GUI. Then there was voice recognition in 1992, then WAM self-driving cars, right? What we have this hype today of self-driving cars. They started long back in 1994, probably even before we were born, right? And then cloud and AI was mixed. This is the new revolution which is going on in, all the sectors, right? Everyone is planning to move to the cloud and automate their tasks, right? And I'll just show you a couple of automative measures by Microsoft in the upcoming demos. All right, so what is the future now, right? We just saw what happened till day. What is the future from here? So again, as I told you, the data being generated is enormous, right? According to research, the data generated in the past 2 to 3 years is the maximum amount of data which was recorded from the, you know, start of humanity. Right. And what will you do with this data, right? What can you do with this data? Let's say you are planning to host your own social media site like Facebook or something like that. How will you manage so many users? How will you manage those likes? How will you manage those shares, what people do, right? So all those things come under big data. How do you manage a whole data set? The whole data which is, can you please mute yourself? Okay, thank you. So big data is one such field where, you know, it deals with the enormous amount of data, right? How will you process the data? How will you store the data? What are the compute powers for that? I think people might have heard of Spark, Apache, right? Hadoop. All those things come under big data, right? If you want to read more on big data, I have a blog published on dev.to. Again, I'll be giving out the link. You guys can go there and see how companies are coming up with big data, right? Let's say, for example, I think you guys might have heard of Airtel, right? They are planning to, uh, solve all the queries, right? In today's advertisement, they just show you like we have these many queries in our database. How will you solve that, right? All those are coming as a boon of big data, right? So what happens here? You just take in the data, you just analyze the whole data. What is this data about? Usually, let's say in terms of Airtel, it is just the complaints which you give that your data is not working, either your network issues, something like that, right? It can be something apart from this. It will be something which is revolving around this whole problem, right? So what can you do? You can train the database and create bots, right? Which can interact with the users. Similarly, one of the practical application, I can just tell you, like, I mean, a case which happened. HP, right? All of us know the Hewlett Packard company. HP, it produces electronics and accessories which you use with your laptops as well. So they had a huge problem dealing with all this data. So what did they do? They went ahead, they collected all the data from the users, right? Initially they had the traditional, the calling customer care call services, but now they are planning to automate it, right? And they succeeded in automating that stuff as well. Then what happened? As a result, the number of queries coming to them decreased a lot, right? So what did the company do? The company aimed at customer satisfaction as well as reducing its own tension, right? So what was the key it used? The key it used was the data which it collected. So that is how data is being, it's a fuel of today's industry. I can tell it in that simple words. Like, data is the fuel of today's industry. Whatever you do, data is involved in that. Then comes the compute part. When I say about the data involved, when I say that it's this amount of data, right? It is going in yottabytes, right? In the order of 10 to the power of 24, right? That's the order of data which is currently being generated, and no doubt because of this pandemic, this will even go higher. Let's say, for example, Microsoft, the Teams platform which we are using right now, right? This didn't have these much of users compared to this. Now what is happening? Everyone is going ahead with this video conference things, right? And again, when people switch over to the internet, there is a problem that data is being generated and it needs to be handled. Again, Teams is very efficient in handling the data, right? Microsoft has its own cloud where everything is taken care of. So we don't have any glitches in Teams right now. In fact, they're adding more and more features, right? So that is how will you do all this stuff? What do you need? You need a compute power, right? And that is what the next thing is about, the compute power. How will you compute this data? What is the power you need to compute this data, right? Then comes, okay, compute power is ready, and the data is ready. So what is the next thing? The next thing is powerful algorithms in order to train this data or do whatever you want, do all the manipulations you want with this data to get the useful information out of that, right? All the data is not obviously useful information to us, right? So something like that. So powerful algorithms are needed. So we'll just see a couple of basic algorithms today. Like, I'll be telling you about, I think, two-class decision tree, right? And but again, there is a huge scope of development of powerful algorithms. Then let's see. I spoke all this while about what is cloud, what does cloud do, right? What are the benefits of the cloud now? Well, the first thing is it's available 24/7. Like, usually when companies switch over to the cloud, right, you have this resilience problem, or lagging, something like that, latency and all those stuff. So this is taken care by the cloud vendors, right? So they make sure that the cloud is available, like the resources available for you to use, even though there is maintenance which is happening in the backend, right? There'll be obviously all the servers won't work well all the times, but even then the cloud won't let you down, right? It gives you all the opportunities to carry on your task, right, even without damaging one single service of yours. The next thing is privacy, right? This is a major concern to all the companies when you think of the data being generated. Obviously you won't like to your data being leaked out, let's say your date of birth or your health status or something like that. So when companies move to the cloud, what they look for is the privacy, right? How secured is your thing, or how private is your thing, right? So what happens here? I mean, I'll take up privacy and security together because they go hand in hand, right? So what happens in Azure, once you create some resource, right, and you upload the data, that data gets encrypted and no one can decrypt that data back, right, except the key which is available for that. You'll get a key once you create a resource. So once your data goes into the cloud, let's say Microsoft Azure, right, then your data gets encrypted. No one in the world can access the data except you, right? I mean, you're the, let's say you're the vendor, right? You're the vendor and you want to access the data. Yes, you have the permissions because you are the one who created the resource, right? Apart from you, no one can, access the whole data whatsoever. Not even Microsoft can access that data, which is in its own data center, right? That is the amount of security which Microsoft provides in its cloud called Azure, right? Again, coming to the cost, let's say you don't use cloud, then you have to go ahead with your own solutions, right? Let's say servers, you have to stack up the whole thing. Then there comes something called as capex and opex costs, capital expenditure and operational expenditure, right? What do you mean by capital expenditure? Capital expenditure is nothing but your investment. Once you're about to begin something, what investment do you put into that? That is called capital expenditure. And this is usually high if you want to prefer your own server stack, right? It cannot be lowered at any cost because you have to have a good server, then again have a cooling effect for that, and again there are many more things. And if your website grows ahead, and then you have to increase the server capacity, right? That is one thing which is high, the capex cost. Then comes the operational expenditure, that is the opex cost, right? So what do you mean by opex cost? Once your server starts functioning, right, what and all do you need? You need electricity for that, let's say to run your server, or even to cool the server or something like that. And then you need internet for you need high speed internet so that your server doesn't go down. No one likes a service which goes down frequently, right? So you need all those stuff to be taken care. What happens in a cloud? All these things are taken care by your cloud provider. Let's say here Azure, it is taken care by Microsoft. So what you have to do is you have to just pay for what you use. Let's say yeah, electricity bills, right? So what do you pay for the whole electricity which is being generated? No, right? What do? You just pay for what you use. Let's say you have used these many units of electricity this month. So your bill comes with only that many amount of units, and you have to just pay for that units, right? Similarly, you will have to do the same thing with the cloud. What you use, you pay for that. You don't pay for the unnecessary things which are there, like the hardware or something like that. It's just you're hiring a hardware from this uh, cloud. Then comes scalability, right? So what happens in a scalability thing? What do you mean by scalability? I just told you about the CBSE results in the initial phase of this webinar, right? So what happened yesterday? The users who access that particular website increase exponentially, right? The whole I think across India, everyone wanted to check the results first. So what happened? Their server was not able to accommodate that amount of processing at that particular time. So what happened? It broke down, right? And that is why I think most of them had faced this issue of server not working or something. The page cannot be reached, something like that. So what is the solution for this, right? This is the problem. So what is the solution? Switch over to the cloud, right? Have you ever seen Amazon website or Flipkart website crashing during a big billion day sale or something like that? No, right? Even though on the big billion day sale, the amount of users increase exponentially there, right? So how do they tackle this? Well, the answer is very simple. It's the cloud, right? What happens in a cloud? Once you have created a particular resource, it gets auto scaled, right? You need not manage it manually. Like let's say I'm having a big billion day sale, so I'll go and do this. No, once your users increases, this what compute power you had decided, let's say 4 GPUs, that becomes 8 GPUs on its own, right? Once your users decrease, again it comes back to 4 GPUs. So this is the scalability which a cloud has on offer. Again, Microsoft Azure also has the same thing. So what are the tools used to access the cloud? One, again, I'll just show you. It's called Microsoft Azure Portal, right? You can go there and access your resources. Then comes Visual Studio. I think most of you have heard of Visual Studio, Visual Studio Code, right? Through that also you can access your resource which is there on the cloud. Then comes GitHub, again owned by Microsoft. So they have a good seamless connectivity between the Azure portal and the GitHub. Then comes the Power Apps. I just told you something about automation, right? People like to automate things. Let's say I'm hosting this webinar. So what do? I just create a form and I just automate the things there. I don't, like to send the emails individually. So what I can do, I can create a flow, right? All those things comes under Power Apps. So you can automate your stuff very well. Let's say you're creating a project, right? You need an alert from time to time. So what you do, no need to trigger it again and again. So just give a trigger option once, it keeps triggering again and again, right? So then comes Power BI. BI stands for business intelligence, right? This is just to monitor your data. It is very beneficial in case of IoT, if you might have heard Internet of Things, right? Wherein the sensor data comes in directly and you need to visualize the sensor data. So what do? You can go ahead and link it with Power BI, right? There are many more steps before linking it directly to Power BI. You'll have to use a Azure service and then link it. So speaking about all this, let's say what is the global network of Microsoft? Where are all the data centers located? Right. So as you can see that it has 54 Azure regions across the globe, right, and 100K plus fiber and subsea cables, right? And now Microsoft is planning to have a data center under sea. I think you might have heard this. They are planning to do that. Then edge is the edge computing, like the fastest computing which is available, right? There are 130 plus edge sites. This is especially useful for your self-driving cars. Then 200 plus express route partners. All right. So even in India, there are three data centers which are located. All right. One in Hyderabad, one in Delhi, one in Kolkata. So now speaking about all these things, let's enter what is AI, right? What does AI do and what do you actually do with AI? So AI is nothing but providing your intelligence artificially, which means computer tries to mimic you in its own way, right? So computer can't learn from you directly, right? Anything can be AI powered, right? It can be a robot, it can be a computer, it can be a smartphone which you have in hand, right? It has a Siri or Google voice assistant. In if you think of your computer, it has Cortana, right? So all this, what would they try to do? They just try to mimic human intelligence, right? They just try to respond to your queries. If you go and say, hey Cortana, I want to know today's weather, right? You're just speaking to Cortana as if you're speaking to a human, right? So that is what artificial intelligence means, right? Computer mimicking human intelligence. Again, as I told, intelligence refers to your sense, I mean, what you respond and how you accept the things, right? So that is what happens here. Then comes the machine learning part. It is a subset in artificial intelligence, right? This actually deals with the statistical methods. Let's say it actually deals with the data which is fed into that previously. All right. So what do I mean by statistical method? Statistical method means somebody else has collected the data for you, or you can start from the scratch as well. You will have to create something called as a data set for that, right? We'll just see all those things later. But as of now, let's just think that it is a branch of AI, right? Let's just understand it this way. It is a branch of AI which deals with the statistical methods to improve your task. What can it improve? We'll see it in a while, right? Then comes deep learning. This is the next step of machine learning. I can say it in this way, because when your data is very huge, right? Not equal to big data, but it is comparatively huge than your machine learning, then I think you can go ahead with deep learning frameworks, right? And from there are a lot of things which open up to you called neural networks and all those stuff, right? So all those comes later where system can train itself. It comes under a thing called reinforced learning, right? I'll just tell you what is reinforcement learning in a while. But before that, let's understand how a AI system works, right? So it has these parts as you can see on your screen, right? It has an intelligent agent, it has an environment, it has a percept, it has an actuator, it has agent function. All right. So first let's see what is intelligent agent. Intelligent agent is a consisting package of all these three things which you can see: sensors, functions, and actuators, right? So this is the brain of AI. I can just say this is the brain of your whole system, what you're planning to develop, right? So AI system's brain is intelligent agent, right? How can you create one? You can create it with a low code platform, what you're going to see today, or else you can go with the traditional method of, coding with Python, R, or any language of your choice. Then comes the environment, like where is your AI system going to interact, right? That comes the next, that becomes the next part of your AI system. Where is it going to interact? For example, Cortana, where does it interact? It interacts with the human. So that becomes its environment, right? And let's say you have created a robot, a vacuum cleaning robot. What is its environment? It's the floor, where it cleans the whole floor, right? That becomes the environment. So in case of self-driving cars, what is the environment? As in the example, it's the people or road, the signs which are there on the road, or the traffic lights, something like that. Then what do you mean by percept? Percept is this thing which gets the information into your system, right? That can be a sensor, that can be a camera, that can be a memory. Memory in the sense the databases which we use, right? Also, even a data set is a percept. Then comes actuators. What do you mean by actuators? Once your data is processed, your system should give out something, right? That is the main reason why you have trained your system. So that is what actuator does, right? It comes out in the form of actions. And this action is triggered by an actuator. What are this actuator? What are the examples of this actuator? It can be voice in terms of in the case of Cortana, Siri, or Google Voice Assistant, right? It can be motor if we just discussed about the vacuum cleaner, right? So it can be a motor in that case, or it can be an information, where we'll be seeing today. What do I mean by information? Where you can predict things, or where you can do some cool stuff out there. And then comes agent function. What is the agent function? Well, this is actually, I can call the main brain, like the major thing where the whole computation takes place. Everything of your AI system depends on this. Though the intelligent agent is like the whole body of your system, the agent function is like the head or the brain, right? The main brain of your system is the agent function, because this is where you write your code or do whatever stuff you want, right? The logic lies in this particular component. Am I clear till here? You can just respond in the chat. Okay. So now let's go ahead and see what are the branches available, right? Many a times you have seen that there's a misconception that AI, ML, DL, everything, every term is, just thrown out there into the world, and you get confused. Let's just clear that first. Okay. What is artificial intelligence? As I said, it mimics your human intelligence, right? So that is the main branch which has all the other sub branches in it, right? So artificial intelligence is a combination of all the sub branches which are present in that system, right? What are the sub branches? As of now, just we have machine learning and deep learning, but I'll just tell you later what are the other sub branches in this, right? Let's now just focus on machine learning and deep learning, right? So what is machine learning? A subset of artificial intelligence where you use statistical methods, right? You get in the data, you work on your data, then get the system out of, I mean, the results out of that. That is what your machine learning does, right? This includes a subcategory. As I said in the first slide, when you have more data, like you have, let's say you have 1,000 rows and columns. Let's say when you have 10,000 rows and columns, or when you have 1 lakh rows and columns. So what you should do? You shouldn't stick on to machine learning at that time. You have to go ahead and create a deep learning model, right? That will give you much more accuracy. Like the prediction is much better in that. Okay, Chris has a question. In the meanwhile, you can, okay. There is nothing to download, Chris. You can just use your internet. It's all on the cloud. There's nothing to download as such. You just have to have a Microsoft account in order to access that. All right. So then comes the deep learning set, as I was just explaining now. So it can train itself, right? When there is that amount of data present in your database, it can train itself, right? Once you just create a model and just leave it out, it has something called as epochs, levels, and there are a lot of things like neural networks and all come into picture. So let's not discuss more into that, because today's topic is just machine learning. All right. So that is how we differentiate between AI, ML, and DL. So if someone comes and tells you, hey, AI, what is AI? So then what you should say? It is nothing but mimicking human intelligence, right? And the subsets include AI, I mean, ML and DL, and many more stuff. So what are those many more steps? Let's just see it now. So machine learning is the first branch. It has predictive analytics and deep learning. We'll be dealing with predictive analytics today, all right? And deep learning is also another thing in machine learning itself. I'll just show you a couple of examples which are already there on our software which we are going to use. Then comes your natural language processing, right? It has classification, translation, and data extraction. Again, there is a low code platform to perform all this action. All these things which you're seeing on your screen, even without, with a minimal coding available, right? Let's say you want to do things, but you don't know how to code, right? Or you're not interested in coding. You just want the things out. Well, the solution is here with Microsoft's all, cognitive services, ML Studio, ML service. You can even automate your ML tasks. All right. So that is the amount of services on offer. Again, NLP has classification, translation, and data extraction. So let's say you are given a video, right? And you're asked to take out some, and assuming that the video has some cuss words. So such cuss words should be censored automatically, right? So what do you do? One thing is you can just sit and open the video. Okay, then say, okay, there is a cuss word at 1 minute 14 seconds. So I'll just censor it there. Manual thing, right? The next thing is just feed it into your NLP model. So what happens? Your NLP has, when you train your NLP model, there will be a couple of words which are treated as cuss words. So what happens? These cuss words are removed from that particular video, and it even tells you what is the cuss word present in your model, right? So that is how NLP works. Just a classical example I'm giving you. Then comes text to speech. I think you guys know this. Alexa and your Cortana, Siri, Google Voice Assistant, all are, your example for the speech. Then comes the expert systems. I mean, this is the finalized system which you have, like, a machine which you develop, a small machine which you develop, right? Then comes planning and optimization. Well, once you do your model, you'll have to make sure that it's up to date, it is working smooth, or else there will be something called as biasing, AI biasing. Where, again, that is a huge thing to talk about, because AI biasing is a threat to the society. Because I think there is a very good classical case study of this. It's called Compass, COMPS, Compass. Okay, where this particular model was supposed to help the judge in US courts, right, to just assist him whether there's a probability of this particular accused in the court, being a repeated offender again and again. So what this AI system was trained was, the data was not that up to the mark. So what it did, it just tried to sort out blacks and whites. All right. And and it was a kind of, biased towards the white, I mean the blacks, right? And every time there used to be a black on the court, it was like, yeah, this guy might commit the crime again. So this was a threat to the society, which was again, it was rectified later, but again there were many more things like this which happened in the past, right? So again, planning and optimization is very, very much necessary when you are working with AI, right? If you want to know more about AI bias, I'll just share an article. You guys can read through that, right? It is a series of 3 blocks. Then comes image recognition. I think you guys know this very well. Your face unlock in your smartphones, right? They work on image recognition. Machine vision is again a part of that, right? Image recognition also can be done without any codes using the low code platform which Azure has, right? Then comes the final part where you see humanoids or robotics comes into picture, right? The humanoids which you can see. Well, what are these humanoids? The best example is Sophia, right? The Sophia is one of the good example how AI can, mimic a human very well. So all those are, the sub branches of artificial intelligence. So if you want to conquer the whole thing, so you'll have to be good at all this stuff, right? That is artificial intelligence in a nutshell. Okay, coming to today's topic. Uh, well, when we first glance, right, we'll just say, okay, machine learning can do anything, or this can do anything. But no, let's just see what can machine learning do or data science do. Okay, the first question it solves is, there are only 5 questions. There are only 5 questions which are solved by this artificial intelligence or data science, right? Not artificial intelligence, the data science. Let me be precise, not AI, it's data science, right? So what is the first question it solves? Is this A or is this B? Right? What is it doing? It is classifying things into two separate categories. Right? So that is the first question which it solves. Is this A or is this B? Okay, they cover a huge amount of algorithms called classification algorithms, right? And that is what we'll be dealing today. We'll be handling one of the classification algorithms, and I'll just give you more resources so that you can, go ahead and explore more on that. All right. So that is what classification does. Is it A or is it B? Okay. The classical example is, will this event happen or will this event not happen? Right? What are the chances of this event happening? Is this like more like probability? Right? Then comes the question two, is this weird, right? As you can see in this picture here, right? This picture over here, there are 3 dogs and 1 cat, right? Here it is very easy for you to identify. I mean, the cat is looking weird apart from like unlike the dogs. But let's say you have 1,000 dogs, right? 1,000 dogs and there is some 1 cat in between. So how will you identify that? Right? So again, the dog will chase away the cat, but let's not get into that. Let's say you have pictures of cat and dog. All right. So the best thing to do this is the anomaly detection algorithms, right? What is the classical use case of this? Your credit card fraudulent transactions. Let's say your credit card is being used, let's say somebody else tries to use your credit card without your permission. Let's say a hacker, right? What happens? At times it blocks the transaction, right? Why does this happen? Because your bank, your particular bank provider has use this algorithm, right, in a much more optimized way, so that your card can, the whole system can detect that okay, this person's card is being used in a weird way and it is not supposed to happen. So what it does, it immediately blocks it and sends you a SMS, right? So your card is being activated. If it is you, and there might be a message which comes up to you, if it is you, please press yes, then we'll allow the transaction to happen, right? When does this happen? Well, let's say the IP address might have been changed where you usually never go. Let's say people from Manipal, right? You either deal in Manipal or you either, have a transaction in Manipal or you have a transaction in your hometown. Let's say you have it somewhere in between, right? That's a fraudulent transaction, but not all such transactions, not all such transactions are fraudulent, right? Some might be done by you somewhere or the other, but again, there's a system which is very precise, which can detect this to a good accuracy level. Then comes uh, the question three, how much or how many, right? This has a different set of algorithms called regression algorithms, right? I think a regression is one of the chapter which is there in math. The same thing is carried ahead to your machine learning. All right. So how much or how many, right? Let's say, will there be an earthquake here, or at what magnitude will it happen? Right? Can you predict it? Right? That is what happens here. The classical example is your weather, right? It is not raining today, but will it rain tomorrow? How will it tell you, will it rain tomorrow or not? Based on the previous record it has, right? Something like that. That is what regression algorithms do, right? Then comes the clustering algorithms, right? How is this organized? Let's say you have 10 red balls and 5 blue balls and 3 purple balls. All right. So all of these are mixed together. So what your classification algorithm does, it just separates out all the balls and arranges it and tells you, okay, this is a cluster of red balls. This is a cluster of purple balls, or this is a cluster of green balls, something like that, right? So this, you can think of the application here. Let's say you're browsing through your internet. All right. You get suggestions in between. You go to Amazon and then you just see, okay, I want to buy this cool little headphone. All right. So what happens once you come out, let's say you have purchased or you have not purchased. What happens the next time when you log in, you'll see, okay, we have some suggestions for you. How is this happening? Again, clustering algorithms come into picture. Again, but this is the most simplest way in layman terms I'm telling, but this is not what happens in the actual clustering. In the actual suggestion thing, because that is reinforcement learning again. But again, in a nutshell, to for you to identify what is what, how to differentiate things, this is a good example. All right. Then comes, what should I do now? Right. I think you all might have guessed it, the Google car, right? The self-driving car. What should I do? I found an obstacle. What should I do? Should I go to the right or should I go to the left? Or should I stop? What should I do? That all these are dealt using reinforcement learning algorithms, right? So these are the 5 questions which data science can only answer. And can you mute yourself? Okay, thank you. So the next thing is, let's come to the main part of machine learning, right? So we have supervised, right? We have unsupervised, and then we have reinforcement. So these are the 3 types of learning, like which your machine can learn through, right? The first thing is the task driven. It has classification or regression. As I told you, what can classification do? We just saw in the previous slide, right? What can regression do? We just saw it in the previous slide. So this is task driven, like there is a task which you ask it to do. Let's say classification, you ask whether it is A or whether it is B. Or in case of regression, you tell, will it rain tomorrow or will it be sunny tomorrow, right? You'll ask something like that, right? That is something called task driven. Then comes your unsupervised, right? What is this is something of data driven, right? What does this do? This is, let's say, clustering, for example. I just told you it segregates the data, right? It arranges your data in a much simpler way, or much organized way for you to carry on your task in a much easier fashion, right? And something like that is association as well. Then comes the reinforcement learning algorithms. These are, software component learns and reacts on its own. There is no need for a master to do this, right? You need not be behind this and train it again and again. Once you give it, it is good to go. It goes ahead and gives you the outputs, right? So the classical example of this will be your YouTube recommendations or your Amazon recommendations. Clear? Am I clear till here? You can respond in the chat. Am I clear till here? All right. Okay, now comes the data mining, right? What do you mean by data mining here? First thing is the cleaning, right? You have to clean your data. Not all the data is clean, well clean for you. Then data processing, right? We'll see what all does this mean in today's particular session, right? Processing and then exploration, model ready data, then algorithm selection. Usually what happens, you have to code a lot in this first session, right? Cleaning, processing, and exploration and understanding. But here there is will not even write a single line of code, right? So it is totally free for you. You are free today to perform your regression analysis or your classification analysis, even without using one single library or one single piece of code in your whole session today, right? So let's just go ahead and see what is data pre-processing. I can tell this is the heart of machine learning or your statistical method, right? Your data should be accurate, right? It should be in a state where it can give you some useful output and not some unnecessary things out there, right? So data pre-processing has data reduction, data cleaning, data transformation, and data integration, right? Not all the data is in a set format, right? Let's say you are planning to use a CSV format. Not everything is in CSV format. Not everything is like it can be in your comma separated version or TSV format or something like that. So what do? You have to clean your data first, right? Cleaning up the things comes first. Then comes the data reduction. There will be redundant data in your data set, or there might be some data which is not even needed, which is a total outlier, right? I can tell it's an outlier in your whole process. So what you should do, you should reduce such data. Unwanted data should be removed. Then comes data transformation. What do you mean by data transformation? Data transformation is something where you transform your data so that it is well trained, I mean, well prepared to perform, to be attached to a good algorithm and give you good output. I mean, data transformation can be, I can tell you something called one-hot encoding, right? It's called encoder methods, or there are many more methods. Let's just speak of an example, one-hot encoding. What does one hot encoding do, right? So let's say okay, let's just think of another simpler example. It's called categorical data, right? So any of such thing, any of your machine learning process, right, it is actually dependent on mathematics. It is extensively on maths and nothing else, right? Let's say, for example, a regression. All right, regression, what does it do? You have learned your slope line method, right? I mean, you know, y is equal to mx plus c is your line equation, right? Where c is your intercept, y is your dependent variable, x is your independent, or something like that. All right. So y is equal to mx plus c. So what is y? Y is dependent on x, right? So y is a independent variable. I mean, y is a dependent variable, whereas your x is an independent variable, which is already there. So what happens? Now the same procedure happens in your regression analysis as well, right? So let's say you have 10,000 points. What your algorithm, I mean, what happens under the hood, right? Let's say you have algorithm, even in your traditional machine learning method, what you use, right? What you do, you just go ahead, you just import sklearn, you just fit the linear regression thing, right? That is what we do usually, right? That avoids a lot of coding which is involved in a linear regression. But we don't understand what is going inside that fit method, right? What is happening in that? Have you ever wondered what happens inside that, right? So let's just see what happens in a linear regression, right? So we have y is equal to mx plus c, right? So c is your intercept, all right? Let's say here it is a constant, right? So which you are giving, let's say some sales, like we have a sales database, and this has number of sales. Y is something you have to decide what you predict, right? What are you going to predict out of your whole, what do you call, whole process? What do you want to predict out of it? Because as I told you, uh, regression is all about prediction, right? Is it going to rain tomorrow? Is it going to be sunny tomorrow? Or will the earthquake happen here? Or something like that, right? One of my project which I had dealt with the simple linear regression where I used a simple model and predicted the earthquake happening criteria there, right? So something like that. What was my output? The earthquake happening or not? Yes or no, right? So something like that should be fitted to your y, right? That will predict your output. What should be your x? What is this earthquake dependent upon, or what is the weather dependent upon? If I have to think tomorrow will be a sunny day, what should the x be, right? That will be my previous weather, or it can be the condition the day before. Like, I mean, what is the condition today in a particular location, right? It depends on everything like that. So all these things are actually mathematical, right? What your computer is understanding, your computer is just understanding the numbers behind it, and it is giving you the calculation. So let's think about this graphically, right? I'll just open my paint and show you how things happen. I'll just show you the art, how, I mean, I'll just show you with the paint example how these things happen. Let's say you have two lines, right? Graphically, X and Y. All right. And you have your data points here. All these are your data points which are happening here. Can you see my screen? Can you see my screen? Okay. All right. So all these black points I keep here, right? All these are my data points. So what happens? Your regression line, I mean, the regression algorithm of yours draws a line everywhere to this particular line, right? It does this job under the hood. So such lines are going everywhere, right? So then what happens? It just chooses a best fit line, right? And how does it choose? Well, we have something called as least square methods and all those stuff, right? So it chooses with the help of least square method. What is the best fit line here? Let's say this line here, the red line which you can see. Obviously, it's not up to the scale, but let's just imagine, right? This is your best fit line. So now the prediction happens according to this, right? So I'll just redraw this figure again here. And let have changed the color. Sorry for that. Okay. Yes. So let's say this black line over here is my best fit line, right? So what happens now? All these data points which were here, right? These black dots you can see here, right? These are matched to this. Some actually lie on this, some will go out of this, right? So what happens? Let's say this is a data point here. So what happens here? This is underlying your regression line, right? It is not even up to the regression. It is not up to the regression line as well, but there is this I mean, a significant gap here, right? So there is, that means your this particular point has deviated so much from the predicted value, right? Let's say I have an employee who's claiming me, he wants to be paid around 50,000, right? But let's say he's, I don't know what went inside him. He could have actually asked me, according to my model, he could have asked me till this 60,000. Let's say this line is 60. Okay, this is 60. He could have asked me till 60K. Okay, but this guy on the other hand, he just asked me for 50K. Okay, probably, I don't know, might be many reasons, right? But what my particular algorithm told me, okay, you can expect that this particular guy, let's say this person Y, okay, I mean this person M, okay, all this come in our equation. Let's say this person A, okay, this person A, he might demand you till 60K. So I was ready, I'll pay you till 60K, right? But what happened? He just asked me till 50K. So yeah, I was very happy and I hired him, right? So this is a very classical example. I mean, a hello. Yeah, am I audible now? You guys can respond in the chat box. Am I audible now? All right. So where did I stop? I was speaking about the regression algorithms, right? So this is how regression works under the hood. As we saw, everything just happened with a maths behind, right? That is y is equal to mx plus c, right? Let's say this line was just a representation of this thing in graphical method, right? So this is how things work in machine learning. Actually, everything is some everything deals with math. There is nothing apart from math here, right? So coming back to our slides, right? So that is why you need to take care of your data. Let's say you have a data which says a city, let's say Bangalore, let's say Manipal, let's say Kolkata, let's say Mumbai, right? But what are these? Bangalore, Kolkata, Mumbai. What does your computer understand? It's just a set of string, right? It doesn't understand, okay, this is Kolkata, this is Bangalore. Oh, should I differentiate in this way? No, your system doesn't understand it that way. What your system does, it just thinks, okay, this is some random string which a user has given me, right? So if you keep such things in your data, I mean, in your data set, what is going to happen? Can you just think what can happen? The whole thing of, I mean, the whole purpose of keeping that particular column is useless, right? Because anyway, a machine, I mean, is not learning anything from that. It is just a random string for your machine, right? So something like that, right? So you have to do something called as encoding here. Let's say you have created a flag, something like a flag, right? So you created, let's say Bangalore, Mumbai, and Manipal, right? Bangalore, let's say if there is Bangalore, just put a 1 in front of that, right? I'll just show it to you again with paint, right? Okay. Let's say this is Bangalore. Yeah, you can see my screen, right? So let's say this is B, okay, guys, Bangalore. Then this is, let's say Manipal. And this is, let's say, some Chandigarh or something. Okay. So what happens here? Let's create 3 columns, right? Wherever there is Bangalore present, put 1, right? Or some symbol. Let's say it's preferable to put 1 and 0. Okay, this shows that this particular data set, okay, this has Bangalore here. Okay, computer understood that there is Bangalore in this particular data set in this. in this section, right? Okay, then there is no Bangalore in this next data set, so 0 and 0, right? There is no involvement of Bangalore. Okay, Mumbai is somewhere here at the end, right? In this data set, there is Mumbai written. So what do? You put a 1 here and put zeros. Like there is no need to put zeros. It is understood that there is nothing in there. Let's say Chandigarh was here or somewhere here, right? And you can put a 0 here and a 0 here. So something like that, you denote that through these things, through these three things here, that there is some data present there and computer should understand that. So this is what you mean by categorical data. Like this is how you deal with the categorical data. We'll be dealing it today, like in our demo session. We'll be moving on very soon to that, right? So just these are all the basics which you should understand just before stepping onto any algorithm or going ahead, right? So what are the methodology? Again, there is something called as training and testing splits, right? Not all the data you have you should train on that, so that what do you do with the what does universities do with us, right? Or what does a child do? When we were small, what we used to do, our teachers used to tell us, okay, this might come to your portion, just study this much and come, right? And what we did, we just studied all the portion. Like let's say teacher gave us a thing, okay, chapter 1 to 10, I'll be just asking questions from chapter 1 to 10, right? So just learn everything from those chapters and come. Let's say in some, I mean, teacher was just fooling you around or something. She she gave you all the questions from chapter 10 to 15. So what happened? Definitely, definitely you won't go ahead and solve. I mean, you'll not do well in that particular paper, right? So similar is your case with your machine learning. It is just like, machine learning is a child to whom you're teaching everything and you're asking it to perform well, right? So that is what happens in your test train split. So usually what we do, the convention we follow, we keep 70% in the training set and 30% in the testing set, right? Then what is your model? Model is nothing but once you fit your algorithm to your particular code, right? That is what you call as a model. So what does a model do? It predicts the values, right? So this is the thing which we are going to follow today. I think you'll better understand it later when we come back. Okay, let's see what are we going to use today. Okay, we are using classification, right? It is a problem identifying. I think I have explained you everything. So what are the major applications? Spam filtering, fraud detection, OCR, optical character recognition, and machine vision. All right, we'll just see it in a demo now. So I'll just introduce you what software are we going to use today. It is called Machine Learning Studio, right? Where there are two services. One is service and one is studio. We are going ahead with the studio because it's a low code platform, right? Even machine learning service is a minimal code platform, but you have to write some part of code in there. And again, you're welcome to add your code in Machine Learning Studio as well. There are again scripts for that to add your code, right? And publishes models as web services. And again, let's say you created a model and you want to link it to your app. How will you link? The APIs, right? Application program interfaces. So that is how you link it. I'll not bore you much with the Machine Learning Studio explanation. We'll just see the demo in a while, right? And these are all the algorithms present. I'll be sharing this particular slide, I mean, this particular picture on the group later. All right, you can see that. As I told you, I mean, Azure has a lot of services. Cognitive services are your computer vision and all those stuff, right? Low code platforms right there. And AI infrastructure has SQL Server, Cosmos database. I mean, the databases which are available. ACS stands for the container services. As I told you, the container service is given. Then machine learning service. This is what we are going to use today. And we are going to use AI tools, the ML Studio. Then, all right, these are the pre-built AIs. As I told you, the low-code platforms. These are the low-code platforms available for you. Before going ahead, I'll just tell you what API does. Right, it's an intermediate software which links between your app and your application. I mean, your application software and the actual database. Right here, it can be anything, and the services which you're planning to use. Here, whatever you're planning to predict today will come out as a API, and you can use it in your apps. Right. So let's now go on to the demo part of it. All of you guys can now follow up with me as well. Just go to Google, right, and okay, and just type studio.azureml.net, right? it opens to this particular platform and I have already logged in. But in case if you are not logged in, then just go ahead and log in here, right? Just a quick confirmation. Am I clear till here? Okay, some of you were asking for the basics, no? So all the basics were cleared, right? So your basics are clear. Just before we go ahead with the demo, are your basics clear? What does machine learning do? What are the algorithms we use? Why do we use algorithms? All right. So again, AI is such a field, right, which should be used by everyone. Even the chemical engineering people out there are planning to use it, right? They're planning to have a deep learning model to predict the experiment, right, in drug delivery systems, right? So that is why AI is not specific to any field, or it shouldn't be done by a guy who's only doing computer science. No, that was the condition earlier, but now AI has become a field which everyone should do, right? So again, having a good knowledge of AI is, welcoming thing for any industry, like any tech giant, right? Because they expect you to know something in this as well. So let's now move on. I think all of you are signed into your machine learning studio, right? Let's just go ahead. I'll just sign out and sign in again. Okay, click on sign in. Okay, just before that, I'll just tell you what are the options here, right? You can try it for free, right? Again, Azure account is mandatory if you want to go ahead and use the premium services of ML Studio. But in case if you are planning to use only ML Studio to just understand things, then there is no need to pay for anything, right? It is free of cost. Let's say you want to deploy it somewhere, then definitely you have to pay for, you have to pay a very minimal amount. I think if the thing which I'm going to show today is just around the $20 for the whole implementation if you're planning to use it on your any app or something, right? It's just $20 cost. All right. Then there are announcements which happen every now and then. There is a quick guide for you to start off with. Then again, how to do modeling and everything, like pre-processing the data. Whatever we discussed so far is there here, right? When you next time when you're free, you can just go in here and just search it, right? So I'll just sign into my account. Okay, once you are signed in, I think once you all are signed in, you'll get a blank thing here. Unlike mine, because I have already done a couple of, you know, experiments here. But once you sign in, it'll be blank, right? So you can just have a look at this interface here, right? It is something called as a project. Once you are creating a project, then you can go ahead and add the assets as well, right? Then there are something called as experiments. Then the web services. I just told you, right? You can deploy it as a web service as well. So again, that is integrated here. Then let's say you are planning to upload some data set, right? So you can do that as well. I mean, the data set is very necessary for any ML computing applications. But again, you can get your data sets through services like Kaggle, right? I mean, this is a very good resource for you to get your data sets from. Just have a sign in and get your data sets from here. All right. So, but today we are going to use a data set which is inbuilt onto this service. So there's no need to download anything or no need to go anywhere else. Or whatever we do will be in this particular window which you're seeing, right? Then have I trained any model? As of now, I have not trained, so there isn't showing nothing. Then again, your usage, workspace, right? Authorization tokens, right? And this will be unique for everyone. Users, and you can add users. Let's say you are working in a team, right? And you want to add more users. So what you do? Let's say there is a team of 4 members, right? So what you do? You just go here and type. Let's say I want to add myself again. Right, add as what, as a owner or a user, you can choose that and just go ahead and add it. So the user will be added here and he can also see what you're doing, right? this is actually very much beneficial if you're planning to work in a group project, right? That is very beneficial. It's just like GitHub thing. So now, as you can see, there is a new button here, plus the plus symbol here down. And I just click on that. All right, click on that. Then just see, okay, the first thing what you see is the data set, right? Let's say you're planning to upload your own data set. So what do? You can go here, you can choose a file, right? Or yeah, and then you can give it a name, right? Just go here and choose any file here, right? Let's say um, anyone, right? COVID-19 analysis and this CSV data. Right? So this is how you import, and then just give a description. Okay, this is a COVID-19 data set, right? What is the data set type? It's a CSV, right? So again, you can convert it later. So that is the first thing of the data set. Then comes your modules, right? Add many rows. I'll just show you what module is. Create a scatter plot, or all these are your modules which will come in handy once you get going with some experiments, right? But today we won't be using any module. This specially is used when you are going ahead with deep learning and all this stuff. They're actually ready-made. There's nothing to code. Just drag and drop. You're good to go. Right? Then comes a project. It is a preview version, but it's empty as of now, right? Then comes the experiments. This is what we are going to do today, right? If you can just click on this, view more in gallery, right? This is a gallery where people come and publish their experiments which they have done, right? You're free to use this in your own applications. They're open source ones, right? You can use it in your applications. Let's say you are planning to implement in healthcare. See, breast cancer detection, heart disease prediction, breast cancer data set. As I told you, that is what I was telling you just before, right? This particular field is not limited to one branch or one this thing, right? Let's say you are from E&I, Triple E, or something like that, right? You are actually welcome to have these things. All right. So again, medical image recognition. You can just glance through all this, right? It is just here on the top. So, and again, apart from that, there are a couple of basic experiments which are here, right? Apply SQL transformation, then binary classification, direct marketing. Again, the breast cancer one, as we just saw, airplane delay. We'll be going to do this in a very simple way today. We'll be predicting the airplane delays today. Right. Again, this is the iris data set. I mean, K-means clustering, iris data set, compare regressors. As I just showed you, right? I just showed you on the paint. Same thing what I showed in the thumbnail. And so this is how you can just do it. But today you can, if you want, you're welcome to take a model from here and run. I'll just show you later. I have a model imported. So just go ahead and create a blank experiment if you want to create from scratch, right? Well, name it something, right? I'll just name it as demo ML Studio, right? Again, this is a zero code platform, and again, this particular thing, let me just show you what is this. You can just zoom in and zoom out here. You'll get a mini map here once you drag and drop things, right? And pan mode enabling and zoom to fit, right? Let's say you want to fit it to a thing, it's fitting like that automatically. So this is called a canvas, right? You can just drag the items from the left hand side. I'll just show you how to drag and drop and connect the things out there, right? So this is called a canvas. Then let's say the first thing, right? The hard, like, the basic step is getting your data set. I'll just show you how a data set looks as well, right? So I have imported a couple of data sets. As you can see, COVID-19 data and German CSV data is the one which I have. Let's say you want to visualize this data. So what did I do? Just zoom in, okay? Just drag it and drop it, right? Your data set is here. This is called a node, right? This is a node. One is written. This is a node. So you can just right click on that and visualize. Click on visualize. Okay. As you can see, this is a data consisting of 43,721 rows and 8 columns. So what is this data? This data is nothing but the pandemic's rate. How is it going on, right? I have just collected a data set from Kaggle, right? This just shows you about 100 entries, the first 100 entries, visualizations and all the stuff. Let's say you want to understand what is there in this particular country region, right? Just go click on that. Okay, see here. This shows you the frequency and country/region, right? The histogram plot. So the maximum cases are found in US, then mainland China, then Canada, I mean, this is an old data set. Now India is in somewhere fourth, I guess. I'm not sure, fourth or third somewhere. So this is an old data set which I had a long back. Right. So Canada, Russia, Japan, France, UK, Australia. Chris, I didn't get your question. Third. Chris, I didn't get your question. Okay, cool. Okay, so it says India's ranking is third. All right, thank you for that. So India is in the third place right now, but this is a very old data set which I had, right? So you guys can get a new data set from Kaggle, and I mean that's a good thing for you to start with ML Studio, I guess, right? You can predict the current pandemic's rate. What can be much better than it? You can be a good predictor. All right. So confirmed cases are here, and you can see everything, right? What are the statistics? What does the mean? As I told you, this is everything on statistics, right? Statistics and math is the heart of machine learning. All right. What are the unique values present? Okay, there are 3,351 unique values. What is a feature type, right? As I was just telling, you just need numeric features usually or categorical features, right? Categorical features, that zeros and ones which I showed you, they are called categorical features. So we might need something like that. So what this has, it's a numeric feature. All right, math is numerics, so it's good to go. I'll just show you. Yeah. Can you say this? It's a string feature. So this column is not fit to, go ahead and be applied on some algorithm, right? So it's a string feature. What do you need to do? You have to convert it into one hot. I mean the encoding. What do you call categorical feature, right? Then comes this string feature. Again, you can just have a look at a particular data set, but this is not what we are going to use. If you're planning to delete this, just click on this and delete, right? Or you can also do it in this way, click here, delete. So the data set which we are going to use today will be the flight delay. Okay, where is the airport? Okay, let's just take an airport code. I'll just tell you why did I import this. Just before that, I'll just take out the flight delay. Flight on time performance data. All right. Oh, okay. By the way, these are all the data sets which are pre-built in this studio. Once you open your studio, I think the my data set might be empty for you, but the samples will be full of all the same data sets which I'm seeing here, right? So all these are ready-made for you. I mean, if you're planning to predict weather, then go ahead and drag this, right? So today, what we are going to use the default data set, right? You can use this. Let's say you want to import something, right? You want to import it, but you don't want to download it. So what do? You just go import data. Just go here and type import data, drag it here, right? Launch this thing. Where do you want to import it from? Hive query. As I told you, the big data thing, that is Hive query, right? The Azure Blob Storage or web URL where it's directly from Kaggle, right? You can just give in here account name, account key, and you're good to go. But today we are not doing that. Let's just go ahead with the flight time on data performance. So let's just visualize this flight on time data. Okay, can you see on your screen year, right? Okay, here it's showing very uniformly that it's all 2011. Unique value is 1. Obviously, if everything is 2011, then that is the only unique value, right? So the feature type is numerical, right? We'll just see what to do with all the data. Right, then the quarter, again, it's all showing the fourth quarter. And that's unique. I don't think that we'll be using these two. I'll just show you which are the columns we'll be dropping. Right, then the month, right? Then the month is, again, see, everything is in 10th month, right? So again, the unique value is 1. All right. Okay, this is luckily there are all, I mean, different values here. There are 31 unique values. The feature is numeric. All right. The day of the week, thank God there are, I mean, 7, this thing, maximum 7. Right. It's a numeric thing, the standard deviation and everything. Okay, this is a problem, right? We don't need string features here. So we'll have to take care of this, right? Let's just note it down. We have to take care of string features. Okay, what is the originating airport ID, right? It's a numeric feature. Okay, we are good. Then destination airport ID, it's okay, good enough. Okay, this is this departure time and this is a departure block. Okay, I think it's better to drop these two because we can just choose a block size, right? We can just go ahead with the block size. So what is the departure delay? Okay, how much is your flight delayed by, right? Here it is just a 2 minutes delay. I mean, it's 4 minutes early here. Wow, 4 minutes early minus 2. Right, what is the median here? 2. Okay, it's minimum minus 56, which means a flight left 1 hour early, right? And maximum is 14, not 1. I mean, there's a very useless data. I can say like it's almost a day delayed, right? So there are 3,697 missing values. I mean, we have to take care of missing values as well, and it's a numeric feature. Okay, if it is delayed by 15 minutes, it is 1 here, right? Let's see. Okay, can you see it is delayed by 17 minutes? So there is a 1 here. And it is delayed by 2, so it's 0. Okay, so it's better that we go ahead with this thing as it is easy for us to analyze. Again, is it cancelled or all these things? So this is the data set we are going to use. Right. So then just go ahead here. Just a second, I'll re-log in. Are you guys following so far? All right. So are you guys doing it with me side by side? Okay. All right, good. So let's get back. So I just had created a model already. So that just we save on time, right? So I'll be showing you everything again from here, scratch to scratch, right? So the first thing, this is the airport codes data set. Again, you can view your data set from here as well. Okay, I didn't show you this data set, right? Let's just see this as well. Visualize again. Yeah, these are the cities and these are the states and the name and airport ID, right? We might need this. It's better to predict, right? You can just choose an airport and then see, okay, what is the time being delayed? Probably from, Dead Horse Airport, I'm getting delayed by 1 day, right? You would not prefer to go there. Something like that, right? So you can visualize here again. It's a string feature. We have to take care of that. Good. And compare to none. All right. If you want, you can compare it with airport ID. It's a mixed plot. Can you see here? All right. There are 5 categories and everything. So this is your data set. This is how a data set looks like, right? It has 365 rows and 4 columns. As you can see, 1, 2, 3, and 4, right? And it has 365 rows. You can view it as this way or in this way as well, right? Cool. So I think all of you are clear how a data set looks like and what should we do? What are the things we analyze? What did we analyze? We just saw, okay, is it a numeric feature? Yes or no? Is it a unique value? Yes or no? How many missing values does it have? Yes or no? If it is there, how many missing values, right? Luckily, these have 0 missing values. Missing values should be taken care of very well, or else they might lead to inefficiency of your model, right? Okay, I have just joined in 2 data sets. Just uh, drag a data called, a module called edit metadata. Go here, search, drag it, and drop it here, right? And then just connect a node like this. Drag it from here and drop it here. I'll just show you with another data set. I'm just dragging a random data set. Okay, just take a node from here, drag it, and drop. Good. This is how we drag and drop a data set. You connect the nodes, right? If you want to delete a connection, just click here and click on delete from your keyboard. Or else you can do this as well, no problem. Right, so now once you're done, just keep one metadata. Don't do it because I have already created one. Don't do it, we'll go it step by step, right? Just be responsive on the chat, all right? Okay, once you're done getting a metadata node, just connect it from this to this, and then click on it. Click on this, you'll get a blue border, and can you see an arrow here? Just click on that. That you can adjust this as well. Okay, in edit metadata, what should I do? I want to segregate things. I want to make it much more organized. So what do? I just go to launch column selector. There'll be 4 columns here, right? Just click on city, state. I'll just do it and show. Just click on city, state, name, and just click on this arrow. So what is this doing? This is considering the columns which you need here, right? The columns which you need on this side. I mean, these are the columns which you want to work on. You want to rename the column to something else. So that is what you do, right? Let's say you don't want it by names, right? You want it by rules. So again, you can go here and type the rules as well. I mean, airport ID is here. I don't want it. So yeah, I just needed 3 columns which are already there. I think the better way is by name. All right, once you're done, click on the tick mark, right? And leave the rest of the things unchanged. And coming to this new column names, just replace it by dest underscore city, dest underscore state, dest underscore name, right? Just replace these names so that what happens, I'll just show you. This data set, the first data set which you had city, state, and name, right? I just want it to be into a destination city, destination state, destination name. So once I do that, and once you're done with this, just click on the run button, right? And you can do either. You can do run or run selected. Let me just run this module. As you can see, it has finished running. Once it is finished running, just click on this, all right? And then click on visualize. Can you see the names have been changed? Okay, it's destination city, destination name, destination state, right? So again, the visualizations is once you click on this, you'll get. We are just planning. We have just started, modifying our data set. Similarly, get another module here and just select the same columns. I mean, you can just copy paste the same module here, whatever you had edit metadata. If you want to add something here, let's say I am renaming it to destination city. Cool. Just click it. Once you hover over this, you'll get to know what is this particular node for, right? Or if you double click on this, you'll get to know renaming it as origin, right? So get another metadata node and just fix it onto there and just rename it as origin city, origin name, and origin state. Make sure that the indices remain the same. I mean, the origin city should come first, followed by origin state, followed by origin name. Don't mismatch the indexes, right? Because under the hood, it matches with the indices, right? No one knows what goes behind in this particular node. It's a black box for you. You just have to worry how will you work with it, right? It is all like, brilliantly designed by Microsoft for a low code platform, right? I mean, you saw, right? I didn't do any coding so far in Python. If you decide to code in Python, you just have to import stuff, go ahead, do things, import data set, import that, import this, right? As you can see, I have not written a single line of code so far. Are you all done? Just put a quick yes in the chat box. Okay. Okay. Then the next part is just drag and drop this flight on time performance. Just scroll down. Here it is, flight on time performance. Drag and drop it here, right? Drag and drop it. Once you're done connecting both the nodes and running the whole thing, connect it again. I mean, get the flight on time data and keep it on the left. Make sure that you keep this whole canvas neat and clean. It is good for you once you come back after many days and see, oh, well, I did this long time back. So you'll get to know what did I do, what did I not do. So it's better. I mean, this what I just showed you here, right? This renaming, it's just like commenting in your Python code or any code you think of, right? It's just commenting for you to think, okay, what is it doing? What am I doing here, right? It's just for your reference. Cool. Then coming to the flight on time performance, just import the data set. Okay. Then just go here, go back, right? Go back and click on, I mean, search for join data. Right. Under data transformation, it is join data. Just drag and drop it here. Right. So what does this have? Join key columns for left, join key columns for right. Make sure that you don't misplace the flight on time performance towards the right? Make sure that you just keep it towards the left, right? Keep it towards the left because usually ML Studio has a left match case, right? So it's a convention which we follow. Cool. All right, so once you're done here, All right, once you're done doing this, just join edit metadata and flight on time performance and click on the join data, right? Click on that. You'll get a specific an inspector object here, right? Click on launch column selector. Okay. What am I doing here? I'm planning to join my dataset codes and my airport IDs, right? I mean, the airport ID and the airport particular name. Let's say it's in Alaska, right? I want Alaska to be linked to AL. AL code should point that, okay, it is Alaska, right? Something like that. So what you should do, just click on airport ID on your left and just put this arrow, click on this arrow and get it here, right? Once you're done, click on checkbox, right? That is for your left thing. Left thing here is your flight on time performance data set. Then coming on to the right, right? Just again click on thing. What do you want to match it to? What do you want to match it? The airport IDs, right? Matching the airport IDs. So again, click on airport ID, click on this button, it will be here. All right. Okay. Then I think this will be checked. Just uncheck this match case. Uncheck the match case, right? We are not doing it automatically. So we are doing it manually, right? So just uncheck the match case. Okay. Then there is a join type. All right. There is a join type. So what should you do here? You just click on left outer joint. Make sure it is on a left outer joint. I mean left outer join. All right. And in this checkbox, keep right key columns in join table. Just click on that. I'll just tell you what left outer join does, right? I'll just show you what does that do. Okay, I am sharing my screen of Paint. Let me just clear it. Cool. Don't see. Okay. These are the two. I mean, yeah. So what does this do? This is a left one. I mean, sorry. This is a left one. This is a right one. Okay, what does a left outer joint do? Left outer joint, I mean, if you just give no joint, right? You can see there are four options: no joint, left outer joint, right outer joint, complete joint. If you give no joint, it just matches the data of only, like, what is common in between both. That is your airport IDs will be matched, right? We don't want that. We want this to be matched to our flight on time performance data set. So where is our flight on time performance data set? It's towards the left, right? And not towards the right. That's why I told you keep it towards the left, right? I mean that node where you join, right? It should be the left node where you join, right? So left join does this thing. It takes in this whole data. I'll just fill it with paint and show you. This, I mean whole this thing. This is what left join does, right? Let's say you're planning on doing right join, right? Right join does this. It just takes the right data set, matches your thing, and just includes in your right side data set. I don't want that to happen, right? And what does full join do? Full join does this thing. This is what you mean by full join, mixing both data set. I don't want a whole data set to be mixed, right? I just want this to happen. So that is why just click on, I'll just share my screen again, ML Studio, right? So just click on left outer join, all right? Left outer join, and then just close that thing and run the model now. Run the model by clicking on run and this run and then go to run. Done. Just give me a quick yes in the chat box. If you're done, just give me a quick yes in the chat box. Okay, good. Okay, so then just drag another join data. I mean, you can just copy paste this thing as well. All right, then just drag another join data. Okay, and join edit metadata of this destination city and the join data of your flight on time performance and this thing. Okay, once you're done running, I'll just run mine again. It shows the timing as well. Okay, mine is successfully executed. So once you're done, let's just visualize what happened. What did we do so far? Okay, it is showing 21 columns. Just compare it with your old data set. Can you see here? I have added these three columns. Can you see that? Did this happen in your data set as well? Origin city, origin state, and origin name, right? This is what we did so far, right? We just clubbed two data sets. Now, again, we need destination cities as well, right? So we are adding 6 more columns to our original data set, right? So that is what I did here. Again, do this thing, join data. Now again, click on launch column selector, by name, click on destination airport ID and check. Then for right, what do you need? Again, match it with airport ID, right? Match case, keep it left outer join, done, right? Again, run your data. Sorry, run your model, sorry. Run your model. Okay, it's running. Okay, it's taking time. Okay, I'll just stop it here because it has executed this join data node. So I just need it till here. It was planning to do the whole thing, but I just don't want that to happen. All right. So once this join data is done, then again click on visualize. I think the 6 columns. All right. Origin city, origin state, origin name, destination city, destination state, and destination name. All those new columns are added, right? Okay. Now, once we are done with this, as I told you, there are some unwanted data, unwanted columns in this particular data set, right? I just don't want this because, this leads to a sort of uniformity, right? Your model learns with uniformity. Let's say I give you 10 questions and I say, okay, you just learn these 10 questions and come. Your paper will be in, your exam paper covers only these particular 10 questions, right? So what are you doing? You tend to buy hard things, right? You tend to mug up things. So I just don't want that to happen in case of my model. So what I do, I just remove it all the I just remove all the uniformities present in this model, and then what I do, I just keep it out of the whole process. So that is what I'm doing here, right? Once done with join data, go here and select columns. Sorry, select columns in dataset. All right, drag and drop this module here. Click on this, launch column selector. All right, so which are the columns I have dropped? Right, I've dropped in year, I've dropped in quarter, I've dropped in month, I've dropped in day of month, and some redundant data which I don't want. Origin airport ID is not needed anymore because I have origin city and destination city. Then departure time is not needed again. Arrival delay is not needed because I have included arrival delay 15, right? That is more than enough for me because I'll put it in a bucket sort of thing, right? Let's just group things and make it simpler. So I'm just removing CRS departure time, arrival delay cancelled and diverted, right? I'm just removing all those stuff, right? Just select this. Once you're done selecting, send me a yes in the chat box. So I'll go ahead. Are you done selecting? Once you're done selecting, please give a yes so that I'll go ahead. Okay. All right. So once you're done with this, make sure you do that thing right. I'll just paste the things which I have excluded in the chat box. it's not happening. But anyway, I think you guys saw what and all did I exclude from the data set, right? Then once you're done, again run your particular data set, select columns, then again visualize just to check whether, all right, can you see that thing is gone? Here is gone, day of week is there, right? Because it has some variation, so I'm keeping it. It has 1 to 7, right? There are only 7 days in a week. So then carrier, what is this WN? Okay, it's a string feature, but we'll see. What does WN carrier mean, right? Just go ahead and type WN carrier. It is Southwest Airlines, right? WN carrier, Southwest Airlines. So something like that. It includes all the data set. I mean, all the datas. Then departure time bulk. I mean, this 14 to 14:59 is between 2 and 3. Then 1 and 2. Then 10 to 11, something like that. So all these things are there. Now let's go ahead and see whether there are any missing datas. Right? There will be a missing data. It's actually like, missing data has many reasons, right? Some of them might not like to disclose their phone numbers or something like that, right? Or their age or their status, their bank balance or something like that, right? So there are many reasons for missing data. So it is inevitable that you'll tend to get a missing data in your whole thing, right? Can you see here the missing values are 4,717 missing values. So we'll have to take care of that. All right, it's a string feature and missing values are 0. There are 3,697 missing values. Again, here is the same thing. Obviously, if there are departure delays of 3,697 missing values, then bulk also should have it, right? And this has 0 missing values. Carrier has 0 missing values. Then just browse through every missing value, right? Here you just have to analyze. It's just your thinking, no need of coding. Then now let's drag and drop a module called clean missing data. Can you see this clean missing data module? Just drag and drop it here. All right, run. Okay, before running, launch column selector, all the columns, right? I've taken all the columns because I want to check everywhere. I don't want to do it manually. Let's say we had just 8 columns here. What if you have 1,000 columns? You can't sit and do it, right? What is the cleaning mode you want to do? There are a couple of cleaning modes, right? One is mice. I mean, this is a new thing. You can use it or not. A custom substitution value, replace with mean, remove entire row, anything, right? Remove entire column, replace it with mean. Usually we go ahead with replacing it with mean, right? Replace it with the mean. Never try to destroy your data if you have limited data. Let's say you have 1,000 rows, and if you remove 30-40 rows in that, then what will you do, right? Data is crucial. Even though it is abundant, it is crucial, right? Try to go ahead with the replace mean, custom substitution value, or you can remove entire, because here I have around 5 lakhs rows, if I'm not wrong. So I can go ahead and remove, 3,000 in that. It doesn't matter much, right? Or I can give this thing. I can even give which value should I play. I can put it at 0 as well. Right? It depends on your use case, how you have to do. I prefer going with these 3, right? Mean, median, mode, or custom substitution value. You can choose whatever you want. Once you're done, close it, run it, right? Run button is here and just click on run. Once it is done, right? Just let's just summarize what I just showed you. One method of visualizing the data, right? What did I do? I just opened this and I was searching. Okay, there is a missing data. This has 8 rows. What if it has 1,000 rows? You can't sit and glance through all 1,000 rows, right? It is not feasible. You'll end up wasting time. Apart from, like, besides that, you will be bored, right? So what can you do? Well, Azure has a solution for that as well. All right. Go ahead and click on a module called summarize data, drag and drop it here, connect it, right? Run it. Okay. Click on this node, visualize. I mean, see here, it is showing you everything, whatever you need, right? Okay. Days of week has 0 missing count. Carrier has 0, departure has 3,967. I mean, the minimum is -56 and maximum is 1 day delay. Mean is 4.8. I mean, this is a total outlier, right? As I said you what outliers mean, right? Outlier is something that, in case of linear regression, it is something which deviates totally away from the line, from that best fit line, what I showed you. it is totally deviating. That is what you mean by outlier, right? And you can see third quartile, range, sample variance, everything, whatever you need is here, right? And then missing values again here, everything. And again, features are here, which is the numeric feature, which is where is it? String feature, everything's here. All right, following so far, are you all clear? Are you all clear so far? Give me a quick yes. Cool. Now, after this, cool. So after this, just once you're done with cleaning the missing data, now let's again do the same thing. Let's again run. I'll just run the selected particular node. You have the flexibility of running the whole the whole model, or just running a particular node, right? I'll just run this node so that it runs very quickly and I don't have to waste much time. Okay, so it is done. All right, summarize, visualize. Can you see all the missing data are 0 now? Missing value count 0, 0, 0, 0, 0, 0, 0. Okay, now one might think, right, when Microsoft has done so much work on machine learning studio, can't they do this thing, like, take care of your missing data as well? Well, definitely it takes care of your missing data on its own, right? Even without your interference as well. But being a data practitioner, it's our aim, like it's one of our methods which we follow to do it, right? So yeah, our missing data is cleaned, right? Then again drag the edit metadata which we dragged earlier. Now, why did I do this? I want to convert. The next part is converting all our string features into numeric features or categorical features, right? Drag edit metadata and just connect it as shown. Launch column selector. Except departure delay, I think all of them have some or the other way of numeric or some other unwanted data type we want. So just select all the thing, right? And then data type unchanged, keep it unchanged, right? And categorical, there are unchanged, make categorical, make non-categorical. You have to make it categorical, right? As I showed you what categorical does, that 0, 1, 1 logic, right? It is that same thing. Then new column name says no need of this, right? Keep this blank. Once you're done, run the selected model. Okay, it has finished running. Let's just check. Visualize. Okay. As you can see, it has gone. Just click on this. As you can see, it is converted. It is not visible for your eyes, but computer has understood now. It's a categorical feature. Your model has understood it's a categorical feature, and it shouldn't treat it like a variable like XYZ or something like that. Right? Destination state is TX. Right? This is what we did. Now comes the next part, as I explained in the slide as well, the splitting data set, right? You can't convert everything into, training and testing. So let's just split the data now, right? And 70-30 is a split which we follow usually. So just go ahead and get this column of split data. Get this thing here, drag it, click on it, split rows. All right, click on split rows. What is a fraction? Well, what is 70% in decimal? 0.7, right? Just click on that. Yes, you need a randomized split, because again, I said you that mugging up tendency of the system is totally, taken out from there, right? And then random seed, okay, you can set it to anything. Like it just initiates a random number generator. A pseudo random number generator, so that it doesn't take it in order. Like let's say first row is taken, then you never know which is the next row which it takes into the testing and training set, right? That is why I use random seed. So you can give it anything. I can give it 1, 2, 3, 4, 5. I can give it 0, I can give it 1. It's up to you. It just initiates a pseudo random number generator. And stratified split, just give it a true, right? Then on the selected column, this launch column selector, and then give arrival delay 15, right? Arrival delay 15 and done. I mean, you don't want your columns to, mess up right at the end. So that's why you just make it a stratified split, right? Once you're done, just run the selected one. We're running out of time, so let's just quicken it up. Right, our item is done, split data. Right, now the next thing is training thing. Once your data is split, I think you just can see here, visualize here. There are two nodes, right? And this has just around 3,53,000 of 78. That is what 70% of 5 lakh something means. And let's say how much this has. Well, 1,51,319. Right, so this is how you split the data set. Then just train your model. The next thing is just get a train model. I mean, what do you call mode and module train model. Drag it and drop it here, right? Launch column selector. Okay, what should be the predicted? What should be your prediction later, right? That is your arrival delay 15. Just drag and drop it. Like this is what it should be trained for. This is what you're expecting. Will it be delayed or not, right? So arrival delay 15 is what you're choosing here. Done. Select and yeah. So join one node here, and the next node should be a algorithm. This is where the algorithm comes into picture. So which algorithm do you choose here? Is it a will it be delayed or will it be not? There are two cases, right? It can be delayed, it cannot be delayed, right? Regression comes into picture when there is only one case happening. Here there are two cases, right? It might be delayed, it might not be delayed as well. So what are the algorithms which we'll use? We'll be using the two class of where is it? Two. All right. Under classification, there are many algorithms here, right? Under classification, I'll be using a two class decision forest. I mean, this is a good thing, creates a two class. I mean, we have two options as well. So two class, again, there is multi-class as well, but I just need two class. So two class decision forest. I mean, this is an optimum algorithm if you want to use for this particular condition. If you want to glance through other algorithms, just go to machine learning. I mean, you can try it out with linear regression as well. I'm not stopping you there. You can go ahead and try it with that as well. And if you have any doubts, just feel free to mail me later. Okay, evaluate. Okay, here you can see there are in initialized model, you have all these algorithms, right? Scoring, let's just leave it now. Okay, there is regression, clustering, the classification, and anomaly detection. So you just need to drag and drop the thing. Everything is preloaded in this node. Drag it, right? Drag it, select, just drag it and then go here, right? Number of decision trees. I mean, I think computer students might get this better. Trees, right? Everything they look in terms of trees. There is a node, then there are two subnodes for that. I'll just show you how a tree, I mean, how it looks like. All right, as you can see, this is my paint. Right, this is what it looks like. All right, this is a tree, right? This is a very basic thing, but it goes ahead like this. This will have again two, right? This has again two, this has again two. So it goes on like that. That is what you mean by trees. So what is a tree which I need here? You can, for optimal results, you have to keep it the maximum tree you need, right? But here, since I'm just giving it for a demo purpose, I'll just keep it one, right? And tree depth. What do you mean by depth? As I showed you here just a minute ago, right? This is like, what is the depth of this tree, right? This has 1, 2, and 3. So there's a 3 depth, right? Right? These are 3 depths. So something like that. So that is what you mean by depth. All right. So I'll just keep it for 5 simplicity purpose. Again, this is a worst decision, worst thing of keeping it the lowest one. You have to keep it the highest one, right? I just want to visualize it later, so that for that is the purpose I'm keeping it 5. And let this be 128. It's not a problem. Minimum number of sample leaf node, just keep it 34, right? And then just run. Finish running it. Visualize. I mean, this doesn't show you much, right? Ensemble element count, maximum depth is 5. That's the thing what I've given it. Then now it's time to train our model. Like our model is almost ready and out. I mean, we're nearing the end of the whole thing. As I showed you before, we're almost nearing the end of this whole session. I mean, this is the final thing. Then it's just from here you have to go ahead and set up a web service. I mean, can you see that how efficiently I did things without even writing a single piece of code? Right? I didn't even use a single piece of code. I mean, not even a single line. I didn't even import NumPy. I didn't even import any other library in that case, right? I didn't even write a code for dropping columns or editing the things. Right? It's very simple, right? Anyone can do this. Anyone. Like even teach a small kid, he'll also sit and do it, I guess, probably. So visualize. Okay. I'll just show you the tree depth. Why did I keep it low? Right, it is just loading here. Can you see here? Okay, I'll just show you what it is showing here, right? Departure delay. It's asking you, is it greater than 15 or less than 15? Okay, if you say it's less than 15, okay, then it is true. Then it comes here, the next node, right? It comes here. Okay, so then it asks you again, okay, is it destination Minneapolis or not? If it is a yes, right? If it is yes, come here. Then is the origin Las Vegas or not? If it is a yes, go here. I mean, the carrier, which is your carrier, right? XE carrier or departure? I mean, is it yes or no? If it is yes, it goes here. Sorry for that. If it is all right. So yeah, if it's a yes, it comes here. And can you see it's showing that you will be delayed by that the account, like, amount of it's what do you say, measure is 76% chances that you will be delayed, and there are 87% chances you might not be delayed as well, right? Again, this is the worst prediction which I can get, because again, I've not said the tree depth well, and then I've not tuned it well. I've just done it for a demo purpose, right? So yeah, carrier XE, right? If it is a yes, then again, I'm 87% sure that I'll be on time and I'm good to go. Right? So this is how I visualize things. And again, if you want to score your model, test it here, you can do it again, right? Click here, right? And then go to statistics, click here, right? It's categorical label. There is a chance here, right? Zero chances of the frequency is 1.3 into 10 power of 5 of getting delayed or not. So this is how I predicted here, right? This is how I predicted. Let's say you want to set it up as a web service, set a predictive web service, and all right, that's the next step, getting into a web service as well. It does it automatically. There's no need to break your head behind that. It does it automatically. Let's run it. All right, creating a predictive experiment. It's still running. Let's see. Once you're done, you can publish it to gallery, make your experiment an open source one as well, so that other users, other beginners also can come and see your experiment, so that they can use it in their projects. Clear so far? I think we have reached the end of our session now. Right, we have almost done. Okay, it's finished running. Right, deploy now. Deploy it. Again, this might be some trouble for you, because you need some subscriptions for this. Till here, it's free of cost, but I think it can come here. As you can see, I got the API key, right? I got the API key. This is what you use for your applications. Just take it here and put it in your application, good to go. No coding required for machine learning. Done. Right? General, go here. Right? You can see a web service management. Right? This site is cookies, all right. This is loading data now. Web in Studio Classic. I mean, you can test it now, tutorial. I mean, this is a tutorial for you to get started, but mine's still loading. Right, this is a dashboard. This is where you can see how many requests are done. Let's say your user starts to use this application. So you can see here what is the request response, I mean requests, and how many responses are there. Right, what is the latency here? Everything is seen here. How many errors were there? Right, and batch request log, configure, consume. Right, you can consume it, request app template. Right, this is a template. I mean, this is not found. You have to create one going here and go log into Azure portal. Again, you need credits for this. And this is what I told you, might cost around $20, right? Go back to Azure, create a machine learning studio workspace. I mean, a classic workspace. Let's create this thing. I've created one, right? And then you can launch it from here as well. All right. And let's say you want to host it on Azure, right? You decide to host it on Azure. So just go here, app services, create an app service, and you're good to go. Select your enterprise resource group. Again, all these things are explained well in the previous webinar. You can go and have a look at that. I mean, how do you want to publish a Docker container? This will be a website name, right? A region, again, where do you want your resource to locate? I mean, the data centers, which I told you, right? And then monitoring stuff, right? And then you get a resource, like let's say www.your airplane delay.azurewebsites.net. You can share it with your users and they will be able to access it. So again, there are many more ways to consume: primary key, secondary key, batch response. Can you see there's a sample code as well, right? I mean, I didn't use this, but Azure gives you everything. So there we come to the end of this session, right? This was the non-coding session for you guys. Just let me know. You can unmute yourself now and let me know how did you guys feel, or you can just drop a text box. And if you have some questions, you can ask me now. It's open for Q&A. I'm opening the session for Q&A. We'll just wrap it up now. If you don't have any doubts, we'll just wrap it up. Well, just before going, I have one more thing to tell you. Just fill in this feedback form. I'll just share the link of the feedback form. Just a second. Yeah, this feedback form, I'll be sharing the link. Make sure you fill this form to get your certificates, right? And not the previous form. Anyway, I have closed the previous form. Make sure you fill this to get your certificate. Which ones did you select the metadata? After cleaning the missing data. Okay. I'll just see, because even I don't remember. Fill in this form so that you'll get your certificates by the end of the week. You can expect them within a week, right? And the recording will be up on a YouTube channel. Okay, I'll just give me some time. I'll just fix the link just right after 5 minutes. I'll just yeah, I'll just fix it in a while. Just give me 5 minutes. Meanwhile, if you have some queries, you can ask. I mean, I'll solve the one query which is there. Just a minute. Yeah, the link is, I mean, the form is available now. You can start filling it. Okay. So which ones will you select? The edit metadata after cleaning the missing data. All right, after cleaning my missing data, let me see. Because there are too many selections which happened here, so I don't remember actually. After cleaning the missing data, edit metadata. All right. So Venkat, I think I have chosen everything except departure delay. Except departure delay, I have, okay. Except departure delay, I have chosen everything. Anand. Okay. Yes, it is. I'll just send it on the group, or I'll just send it on the WhatsApp group. Achintya. What error is it showing, Anand?